Hi, and welcome to the Assembly Lines Podcast. I'm Chris Torrance. In the past few episodes, we've been building an Apple II emulator using React and TypeScript. In this episode, I'm going to try and take it as far as I can and see if we can get the Apple II ROMs to boot up. So let's get started. In the past few episodes, I've been slowly beefing up my Apple II emulator by adding more and more 6502 instructions and then just increasing the complexity of my machine language programs. So if you recall, I had a rudimentary assembler that I had put together. So for example, I could take a 6502 assembly program like this one here, where I have a bunch of instructions, I have some labels, and then I can actually print things to the text screen. So if we go over to my emulator in the browser and then just boot it, you can see I was just printing out the letters A through D. And what I added between that last episode and this one is support for the beep for the 6502. And then I actually started adding support for all the instructions needed to boot up the actual Apple II ROM. One thing I ran into, which I haven't quite figured out, is the beep doesn't quite work properly. One problem is if you're using Chrome, you have to actually have a user gesture or an interaction with the web page before it'll register any sort of sound or actually execute sound. So you can see I loaded the page, I hit boot, nothing happened. If I hit boot again, then I actually get the Apple II beep. Now, I had to cheat a little bit. And if we go up and look at my sound routine up here, the problem is on the Apple II speaker, when you touch the C030 soft switch, it goes ahead and cycles the Apple II speaker once. And so by repeatedly doing that, you can actually get it to generate a tone. On a modern machine, it's a lot trickier to do that because it's not just a simple 1-bit speaker. Instead, it's really expecting to play tones or actual music or at least some sort of audio wave. So I haven't quite figured out how to actually emulate the Apple II speaker. Instead, what I'm doing is if I notice a write or a read to C030, I just go ahead and I beep the speaker for 0.1 seconds. So I'm not going to be able to be playing any sounds out of this, but at least I can make it sound like an Apple II if it's only just kind of faking it. However, it still doesn't do it when I first load the page. So for example, if I reload, hit boot, you can see it didn't do the beep. And I think it's just some sort of problem with my code, so I'll have to take a look at that. But let's go back to the problem at hand. It's all very well to print text things to the page like this, but we really want to boot up an Apple II. So to start going down this path, I needed to get the Apple II ROMs. And to do this, I downloaded them from the internet, and you can find them in various places. You can't actually redistribute them because the IP is still owned by Apple. However, what I did is I'm just loading these into my emulator. And to do this, I just decided to load it as a very long JavaScript string, and I encoded it as base64. In the README in my GitHub repo, I described the command that I used to do that, and it's just on my Mac, I'm using an OpenSSL command, which can just convert a binary file into base64. And you can see the output for that here. This is actually the Apple II Plus ROM encoded as a base64 string. You can see that I had to put a little bit of JavaScript boilerplate at the top to turn it into an actual string, and then there's another string character at the very end. So this is just the Apple II Plus ROM encoded as base64, and then in my program, if we go over to my instructions, I'm just importing this variable, and then when I actually do my reset for the computer, so let's scroll down to that. So the first thing I do is fill out my entire 64K of memory with just FFs, just to clear everything out, and then I simply replace all of the memory from location C000 and higher with my actual ROM. And then finally, I just set the program counter to the reset location for the Apple II, which is stored in locations FFFC and FFFD. and then I'm good to go. So once I did this, what happened? Well, it immediately crashed because I was missing a whole bunch of 6502 instructions that I hadn't implemented yet. And I won't go through all of those in detail because it took me a long time to just wade through the ones that were missing. And you can see down here at the bottom of my instructions file all of the new instructions. So I had to add all of the add with carry. I had to do the shift left and shift right. I had to add in a lot of compare instructions. But in the end, it actually wasn't that many instructions that I was missing. And so if we go back to my main display program and go down to where the assembly language is here, we can just comment out my parse code. Don't set the program counter to 2000, which is what I had, but instead set it to that reset vector at FFFC and FFFD. And then let's just go ahead and we will run this. So you can see when I save the code, it immediately updated in the browser. I'll hit boot, and voila, we have an Apple II prompt. And the cool thing is, because I have all the instructions implemented, I get everything else for free. So for example, I didn't have to do anything to get support for BASIC. If I just want to go in here and type, say 10, print 2 plus 2, 20, go to 10, I can run this and it all works. Now I did have to put in a bunch of code to actually handle the keystrokes and especially the control characters. So if I hit Control G, now it actually does a beep. And this was just in my TypeScript code to handle keyboard input. We can also drop into the monitor with a call -151. And let's just take a look at the Apple II Plus ROM here. This is the Auto Start ROM. And we're getting all of this functionality for free just because we've implemented all of the 6502 instructions. So we didn't have to do any extra coding to get things like the machine listings to work or any of the programs running like we saw with AppleSoft Basic. It just sort of happens, which is, I don't know, it feels kind of like magic or something. But it's just the 6502 doing what it's told. Now, one thing that I really want to add is a reset button. So you can see I have this boot button here. If I do that, it just completely starts the entire emulator over again. But there could be cases where you get stuck into an infinite loop or some other condition where you don't want to, say, lose your AppleSoft program or whatever's in memory, but you just want to reset the computer. And so I think what I'll do next is add a reset button down here between my boot and my pause. And then I also, you can see I have this limit speed button that I've added. So if I turn off that checkbox, right now the computer's running at approximately 1 megahertz. It sort of varies around that a little bit. Turn that off, the limit speed, and then it just cranks up to as fast as the JavaScript code can go. And you can see we're getting up to around 4 megahertz, which is probably the fastest that I can get without doing a lot of optimization in the browser. But let's turn this back on, and let's go back to my code, and we'll just add a reset button here and see how to do that. In the display file, if we scroll down to the bottom, this is my render function here, where I have all of my React code. And what we want to do is we just want to add a new button between the boot and the pause button. So I'll just copy this, paste it in there, and we'll call this reset and just save that. Okay, now you can see we have a boot and a reset. Now, if I haven't booted yet, I probably don't actually want to make the reset button actually available. So we're going to want to disable it in that case. So I think what we need is we're going to need a different state variable here. Let's go up and see my different states for the 6502. I've got idle, which means we're just starting out, nothing's happened yet. I have need reset, which is actually should be probably need boot. I have another state for when it's actually running, and then I have another state for paused, which is when you hit this pause button here, which is currently not activated. So let's go ahead and we'll just add another one in here, which is need boot. And this will be executed at the very beginning. And now that we have that, let's set the initial state. So it starts out as idle. And then when you hit the boot button, we want to set the state to need boot. Okay, we can leave this one alone for reset, and let's actually add a disabled flag here on the button. So we will just put this here. Actually, let me put it in right there. And we want to set disabled when the 6502 is either idle or needs boot. So that, or, oops. Okay, there we go. We'll save that. Okay, so you can see my reset button is now disabled. All right, and now let's actually handle the reset. So in my advance, which is the function that actually runs the instructions, this is where we actually handle, whether we're going to do an instruction or whether we're going to reset, etc. So what we want to do is, I think we want to rename this do reset to do boot. So let's do that right now. So we'll call this, actually I can do this easier. If I go here, I can just click rename symbol and we'll call it do boot, and that'll rename it everywhere. Okay. And then this one, do reset 6502, this is inside my instructions file. Let's rename that to do boot 6502. Okay. And now save this. Okay. So let's see if we can boot. All right. So it looks like we haven't broken anything, but we still don't have a reset button that does anything. So let's now go back to instructions and we'll add a do reset. Okay. Do reset. Okay, and on reset, I don't want to erase all of the memory, so we're going to get rid of that. I shouldn't need to replace the ROM, so we should be able to get rid of that. I don't want to reset necessarily the accumulator or the X or Y register or the program status. I'm not sure about the stack pointer. I'll have to think about that. I think what I'll do for now is I'm just going to set the program counter to my reset vector. And let's just see what happens. So go back to my display here. And we're going to import do reset from the instructions file. And then down in my advance, we'll just say if the state is needs reset, then we want this to actually say need boot. Okay. Then we want to do the boot. Else, and let's just copy this. Okay. If the state is need reset, then let's call do reset. Okay, and set our state to running again. So let's go over here. We'll just refresh just to make sure. I'm going to boot. Okay, our reset is now available. So let's put in a program. Run. Okay, so we have a basic program now. I'm going to hit reset. Okay, and we can list. Okay, and our program is still there, but it looks like we actually reset. So I think we accomplished what we wanted to with that. So now we have a boot, we have a reset, and we have a pause button. Okay, we have a couple more things to talk about in this episode. As soon as I got the AppleSoft Basic to work, I immediately wanted to try out some programs, but ran into the problem of typing those programs into the emulator, which I didn't really want to do. So I wanted to get paste working. However, I knew that my text area that I'd been using in HTML wasn't really going to cut it once I moved to Apple II graphics. So there was a subscriber to my YouTube channel named TM Barrel who suggested that I use a canvas instead of just the text area. And he was actually kind enough to do a pull request on my GitHub repository with some code. I didn't really want to look at his code necessarily because I wanted to try and do this myself first. So I just decided to try to use the canvas myself. And then I would eventually be able to paste into that canvas to paste in programs. So looking back at my code, I added a new Apple II canvas function, which just returns an HTML canvas. And I can use this now for text or low-res graphics or high-res graphics. Right now I'm just using it for text. And to get paste to work, what I did is I wanted to add a paste handler. I couldn't actually add it to the canvas because I want to paste in text, and the HTML canvas didn't seem to want to accept that. So instead, I'm just adding a paste handler to the main top-level window, just using add event listener. I have a paste handler function now, and this just gets the clipboard data that the person has pasted into that window. And then I added a add to buffer method over in my 6502 instructions. So let's switch over and take a look at that now. All right, here we are in my instructions file. Add to buffer just takes whatever was pasted into that window and then adds it to this keyboard buffer, which is just a global string. That string is used in turn by this pop key function, which just takes the characters off of that key buffer one at a time and stuffs them into the Apple's keyboard soft switch at C000. So the next question might be, well, how do you actually know when to put a new character on that? And in that case, you can just use the Apple's regular way of doing that, which is the keyboard strobe at C010. So now if we scroll down to my memory access function, this is where I handle all of the soft switches. And right now it only handles a few, but eventually there'll be a lot more for things like switching to 80 column mode or switching different graphics modes. But you can see if the program accesses location C010, then I take the character that was in the current keyboard buffer, turn off the high bit on it, because presumably you've already accessed it, and then I just call my pop key method. So if I do have anything that's remaining on that keyboard buffer, it'll just put a new key into the address C000, and then the next time somebody asks for that key, it'll just read it back out. And so it'll just go around and around and around. So let's see that in action. I have some AppleSoft Basic programs that I downloaded off of the internet. This is a Fibonacci program that I found. So if I copy this, go over to my emulator, hit Command V, you can see it pastes it in, and now I can just run the program. So let's just generate Fibonacci's from say 1 to 10. Okay, there it is. Let me run it again. Okay. So this way I can paste any arbitrary code, programs, could be machine language codes, into my emulator and just be able to execute it. All right. So I think that's probably enough for this episode. In the next episode, we're going to take a look at how we can use this Apple II canvas to actually handle low res and maybe even high resolution graphics. All right, I hope you enjoyed this episode of the Assembly Lines podcast. We made some good progress in getting the Apple II ROMs going. The next thing to get going is Apple II graphics, and this will involve a lot of translation between the Apple's quirky memory layout and the actual bits on the screen. If you haven't subscribed to my channel, please hit the subscribe button below. I also have a Patreon if you'd like to get your name in the credits, and I have a link in the show notes for that. Once again, thanks for watching.